In the previous lecture, we have discussed the K-map. We have seen how we can build any expression by using the K-map from any given function. Till now, we have seen the K-map function, K-map expression for only the SOT form. In today's lecture, we will see an example of POS form and how we can build any K-map expressions by using for POS form. Now let's see an example. That is, suppose f1 is a function. f1 is equal to 5, m, 2, 4, 6, 8, 10. So from this expression, we can see that this is a POS form. This is pi term and this is max term. Max term means for only these inputs, the output will always be 0 and rest of the output is always equal to 1. So in case of POS form, we know that if a variable is in its complemented form, then its value is always equal to 1, and if it is in true form, then its value is always equal to 0. So first of all, we have to take the highest digit. So what is the highest digit in this function? 10 is the highest digit in this function. So we have to build an 4 cross 4 K-map, because 10 means 2 to the power 4, maximum 16 combination is possible. So as the highest digit is 10, so maximum 16 combination can be possible in this K-map. So you have to build a 4 cross 4 K-map. First of all, you have to build a 4 cross 4 K-map. Suppose the two variables are a, b and c, d, and this is a 4 cross 4 K-map. We have seen the rules of simplifying K-map expressions and find the following expressions for this particular function. So in our part, we have to write the gray code of 0, 1, 2, 3 respectively. So this is a 2-bit. So this is a 2-bit gray code. So we have to write the 2-bit gray code here. So this is 0, 0, this is 0, 1, 1, 1, and 1, 0. Here is also 2-bit is there. So 0, 0, 0, 1, 1, 1, and 1, 0. Now next step is we have to find the binary term of the terms that is present inside a max term or inside a min term in that particular functions. So what is the binary form of 2, 4, 6, 8, and 10? So 2 means in binary form 2 means 0, 0, 1, 0, 4 means 0, 1, 0, 0, 6 means 0, 1, 1, 0, 8 means 1, 0, 0, 0, and 10 means 1, 0, 1, 0. So you have to write the binary form of the each term present in the each max term. So in case of POS form, we know that for these inputs only the output will be 0 and rest of the output will be 1. So we have to put the 0 in the respective blocks, right? So this is 2 means 0, 0, 1, 0, 0, 0, 1, 0. So you have to put 0 here. 0, 1, 0, 0, 0, 1, 0, 0. We have to put 0 here. In case of SOT form, or in case of min terms, the particular inputs will gives the high output and the rest of the inputs give the low output. So we have put 1 in case of SOT form. In case of POS form, as these inputs only give 0 output, so you have to put 0 here. And this is 0, 1, 1, 0, 0, 1, 1, 0. So this is also 0, 1, 0, 0, 0, 1, 0, 0. This is also 0, and 1, 0, 1, 0, 1, 0, 1, 0. This is also 0. Right, so 0, 0, 1, 0 here, 0, 1, 0, 0 here, 0, 1, 1, 0 here, and 1, 0, 1, 0 here, and 1, 0, 0, 0 here. Next, we have to make the each and individual group. So you can see that only these two can be grouped together. Only this can be grouped possible, and rest of the three blocks cannot be grouped together because it's not the horizontal or vertical blocks, or it's not the inside of the K-map. So these three remain individually. We have to consider these 3 blocks individually. Now, in case of SOT form, we have to find each expression. We have to find each expression in case of product term, and then we have to add the whole product term to get the final expressions. But in case of POS form, as we know, the POS means product of sum form. So in each term, you have to find the sum term, and you have to then multiply each sum term to get the product of sum form, because it's a POS form, right? So first take this group. So if 1 is equal to, first take this group. So this is so A, and if we see this position, so AB means 0 0, A is not changing and B is changing. So as B is changing, you can omit the B, and as A is not changing, so A is 0. In case of the SOA form, as it is 0, we have to write A complement here. But as in case of PS form, if any value is 0, then you have to write its true form, and if its value is 1, then you write its complemented form. As SOP form is opposite to the previous form, right? So here A means 0, so we have to write its true form. So this is A, this is C, and B we can omit the B here because it's changing. We have to see the position of C and D. So C means 1 and D means 0. So C means 1, so you have to write the C bar, and D means 0, you have to write the D here. And each term you have to write in case of sum term, right? In case of SOA form, we have to find each product term and then add those product term. But in case of PS form, you have to take the odd function of each term and then you have to add the overall function, all the terms. So this is A, and this is C bar plus C bar plus D. This is the first sum term. Next sum term is this. So we have to multiply this because this is a product of sum form. So what is the position of 0 here? A means 1. So 1 means A bar here. B means 0. B means B here. C means 1. C bar here. Plus D means 0. D here. Dot. What is the position of this term? A means 1. So here A bar plus B means 0 plus B plus C means 0 plus C plus D means 0 D. Dot. What is the position of this 0? 0 means A bar. Sorry, 0 means A plus 1 means B bar plus what is the position of C and D? C plus D. So this is the final expression of final expression of that particular function. So we can get the expression of each and every variable within it by using the schema only. This is the final expression. Now see another example, then you will be clear about that. Now let's take another example. This is a function f2 is equal to pi a in the bracket, inside the bracket 2, 4, 8 and 11, 14. So you can see that this is a product of sum term as pi is there. So this is product of sum term and this is the max term. For only these inputs are going to be 0 and otherwise they are going to be high. So this is a previous form. Next we have to build the KMF by using this function, and we have to find the expression of this function. So what is the maximum term present here? Maximum term is 14. So maximum of 2 to the power 4 in 16 combination can be possible here. So you can take a 4 cross 4 KMF, maximum of where maximum 16 combinations is possible here, as the maximum term present here is 14. So you have to take a 4 cross 4 KMF here. Suppose 4 variables are A, B, C and D. 4 variables here A, B, C, D. And you have to take the gray code of 2-bit gray code here as 2 variables present for the both side. So this is 0, 0, 0, 1, 1, 1, 1, 0. Gray code of 0, 1, 2 and 3, 2-bit gray code. And this is also 0, 0, 0, 1, 1, 1, 1, 0. And this is also, this is a 2-bit gray code format. It's a 4 cross 4 KMF. Next, we have to find the binary term of each and every max term. 2 means in binary 0, 0, 1, 0. 4 means in binary 0, 1, 0, 0. 8 means in binary 1, 0, 0, 0. 9 means in binary 1, 0, 0, 1. 11 means in binary 1, 0, 1, 1. And 14 means in binary 1, 1, 1, 0. So this is the binary combination, binary form of each and every maxterm. Next we have to fill the key map here. So this is 0010. This block can be filled with 0 as it is a PS form. For this input output will be 0, otherwise output will be 1. We can take the output as 1 or we can remain empty wherever the output is 1, because in PS form 1 means nothing and 0 means only. You can consider the 0 here. So this is 0100, 000100. This can be filled with 0. 1000, 1000. This can be filled with 0. 1001, 100. This can be filled with 0. And 1011, 1011. This can be filled with 0. And 1110, 1110. This can be filled with 0. So see, now we have to make the rectangular group. So these two can be grouped together and these two can be grouped together. Why these three cannot be grouped together? Because we have discussed the rules of KMF, that we have to take the rectangular group in terms of in the power of 2. As 3 is the not in the power of 2, so we have to make the 2 individual group here. 2 is the power of 2, 2 to the power 1 means 2. So we have to make each individual group by taking the 2 terms. So here is the individual group of 2 terms, that is the power of 2, and here is the individual group of 2 terms, that is the power of 2. This 0 can be combined. This 0 can be common for the both the groups, and rest of the elements cannot be grouped together. Next, we have to find the expression of each and every term. So f1 is equal to. So what is the expression of this group? So this is a means 1 and b means 0. So this is a bar plus b, and c is 0. So this is c plus d is same thing. So we can omit the d here. A bar plus b plus c dot. What is the position of this group? 1 and 0. A means 1, this means a bar, plus b means 0, that is b, plus c is same thing, I want to see here, and d is 1, so d bar. Dot. What is the position of this group? This is a bar plus b bar plus c bar plus d. And what is the position of this group? This group is a plus b plus c bar plus d. And what is the position of this group? And this is a plus b bar, a. This is a plus b bar plus c plus d. So this is the overall expression of the particular function. So in this way, we can build any expression of using the KMap for the PS form. So we have seen how we can build the expression with the minimum variables by using the KMap for both the assembly form and PS form. From the next lecture, we will see any logic circuits that converts the gray code to the binary code and binary code to the gray code. So we have seen till now that how we can convert the binary code to the gray code and gray code to the binary code. But now, from the next lecture, we will see that what is the logic circuit of converting a gray code to the binary code. How its practical use is there. How the practical circuits can be looked like, right? So how in which logic the binary code can be converted into gray code and gray code can be converted into binary code. In the next day, we will see that logic circuit diagram. Thank you for watching.